Now that you have all had the opportunity to try out these simple BCA tables on your own, we will work through them together. There will be 2 questions on your test that are considered simple BCA tables. One question like number 1, where you are given moles and you have to find an answer in moles. One like question 2, where you are given a starting number in grams and will be asked for your answer to be in grams. To start off with question 1, we always first write a balanced chemical equation. So our equation in this case is Zn plus HCl yields ZnCl2 plus H2. We then have to balance this equation, and because we have 2 chlorines and 2 hydrogens on the right-hand side of the arrow, we have to put a 2 in front of the HCl so that we now have 2 of each on the left-hand side of the arrow as well. Now that the equation is balanced, we can write out our BCA table, and we can start by filling in the before row. The before row is filled out by using the numbers provided to us in the problem. So it says we have 0.289 moles of zinc. So that goes in the before row under Zn. It also tells us that we have excess hydrochloric acid, and we know that we always start with 0 moles of our products. When we fill out the change row, we know we're going to subtract our reactants and add our products, and we figure out our change row by looking at the numbers provided. Since we only know we have 0.289 moles of zinc, we have to assume we are going to use up all of it. Any other number, any other substance in the change row that has the same coefficient will have the same change row number. So since zinc, Zn, has a coefficient of 1, and ZnCl2 and H2 also have coefficients of 1, we can fill in 0.289 moles in each of those spots. Because HCl has a different coefficient, we need to figure out what number goes in the change row by cross multiplying. So we'll take zinc's coefficient of 1, put it over the number we know, 0.289, and set that equal to the coefficient of HCl, 2 over x. When you solve for x, you get 0.578, and that is the number that then goes into our BCA table. For the after row, we simply solve the table by doing the math. So 0.289 minus 0.289 is 0. Excess minus anything is excess. 0 plus 0.289 is 0.289. Sorry, that's hard to read. And 0 plus 0.289 is 0.289. Then the final step is to look what is the question asking for and to write out that answer separate from the table. So it was asking for how many moles of zinc chloride were produced. So we will write our final answer as 0.289 moles of ZnCl2. To move on to the second problem, sodium chloride decomposes into sodium and chlorine gas. We again first write our balanced equation. So sodium chloride is NaCl, and that is breaking down into Na plus Cl2. If you notice, we have 2 chlorines on the left, or on the right side, and so to get 2 on the left side, we have to put a 2 out in front of the NaCl. That also gives us 2 NAs, so we need to put a 2 out in front of the NAs on the right side. The equation is now balanced, so we can set up our BCA table, and we can fill in our before line with the numbers given. It tells us we have 9.45 grams of sodium chloride, but we're not allowed to put grams into the BCA table, so we have to first convert those grams into moles. So 9.45 grams converted into moles using your mole roadmap means you put 1 mole on top and the molar mass of NaCl on the bottom. NaCl added up off your periodic table is 58.5 grams. When we do that math, we get 0.162 moles. So that is our starting number that goes into the BCA table under NaCl. We know that we always start with 0 moles of our products, and now we're ready to begin filling out the rest of the table. We subtract our reactants and we add our products. Because we only know we have 0.162 moles of NaCl, we assume we will use all 0.162 moles. And then any other substance that has the same coefficient will be the same change row number. So since Na also has a coefficient of 2, we will put 0.162 in that spot. Cl2 has a coefficient of 1, so we're going to need to solve for the number that goes in that change row. To do that, we use the coefficient 2 over the number we know, 0.162, and we set that equal to 1 over x. When you solve for x, you get 0.081. So I plug in 0.08. Again, excuse me for not being able to read that very well. 0.081 into that change row spot. As we solve going down for the after row, 0.162 minus 0.162 is 0. 0 plus 0.162 is 0.162, and 0 plus 0.081 is 0.081. And now we're almost finished, but the question it asked in the problem was for how many grams of chlorine gas can be produced. So this 0.081 is actually a number in moles, so we'll have to use our mole roadmap to convert it back to grams. To do that, we put 1 mole on the bottom and the molar mass of Cl2 on top, which is 71.0 grams. Added up off the periodic table. And then when you do 0.081 times 71.0 divided by 1, you get 5.75 grams of Cl2 for your final answer.